So what does Google Clips do? Google Clips takes, or at least it imagines, the best shot to take while streaming. So it has a machine learning that is analyzing the frame that it looks at and decides which frame or which GIF or which movie should be taken. Those are some examples, randomly chosen. This is the head of Google for Google Clips. And the nice thing about Google Clips is that it's not invasive. And then we're gonna come back to that point of not invasiveness, which is one of the main objectives when you're building on devices on AI. Are you building any device on AI with AI embedded, machine learning embedded, some apps, projects? Yep, okay, at least one. So the most important things that we realized by starting, and then we're going back to our users, by starting Google Clips and working, partnering with them, is that we need to find the needs of the astronauts, and we need somehow these needs to be able to teach it to the machine. The machine should be able to learn what are the needs, which in the case of the pictures or the shootings, it's not really an easy task because you don't know the user, the end user, if she is gonna like what picture Clips took. And in our case, if you make something wrong, especially in the ISS, you have a death sentence. And if you're building for space industry, it's regulation are really a pain in the ass, meaning that you spent almost 1.5 years trying to figure out which regulation you have to follow, because there's no, it's not a normal app when you have a feedback. There's no time for feedback your app, so you need to be prepared, and your prototype need to 120% working for astronauts. So going back to what we need to do, when we are building an app with AI, you need to bear in mind that you need to build trust into your user. You need to, as we said, not be invasive with the prediction or projection you're doing and you're giving information to the user. The user needs to be the director of what he or she chooses when using your app or using a device. And sometimes we have these quote that AI knows more than we do, which from my personal point of view, it's not sustained. AI is good for quick computing. AI is good for quick prediction, which means there are mathematical computing behind that. It's not that it predicts things without any input or data. So this one is the patterns that we were looking at when we were working with Google Clips. As you can see, those are pictures taken randomly, and the device put them together in either a time frame or a better to view pattern, so to be able to show to the user which frame she should use. I'm going to go and show you a little bit of the crew timeline. And looking at that, it's a little bit like the pattern we saw before. It's confusing. Looks like an Excel spreadsheet. So the crew line, and if you can see, there's really tough tasks going on. And with machine learning, we were trying to predict which better task to do when. If you can see, and this is interesting, the black and white tabs are the orbits that the ISS does around Earth, meaning that it adds to the user a stress inside. So the user astronauts are much more stressed because they don't understand when it's day, when it's night. They just need to follow these data sheets. And over here, if I'm asking you, what do you see? You don't understand it. And that was our first reaction when they show us these caution and warnings, meaning that pages like this, you need to train users, astronauts, to understand what all this means. Well, of course, the red is you're not doing something right, but that's the only thing that we could code up. And that's the communication status. When they have a problem from the ISS to the mission control, they actually call mission control at any time, and mission control should be there answering. And they are exchanging these Excel sheets up and down, sending them, downloading, uploading, downloading and uploading. So with the machine learning, what we're trying to do, we're trying to put all this kind of information and to give to not clips, but our device, to give a pattern of filtering that could give the exact next task to the astronauts without him, her, having to go through the spreadsheet. There's a little bit of an architecture we used. So you can see dialog manager, process manager, OWL, well, the database, ontology, and those are all the executions we did. And that was our first prototype of an architecture. As I said to you before, I'm sorry, I cannot show you the Python thing. We ran almost 6 months of reviewing and testing. And the interesting thing is that we spent 1 year working on a machine learning. The machine learning were working pretty well, but the prototype was not working. And that's why I came out with this presentation, in order to be able to share with you some perspective that we took in mind and we bear in mind when doing the next step of our prototyping. So what we thought, once that everything wasn't working, we thought that we needed the machine to understand how to become an expert astronaut, meaning that we shouldn't teach the machine on where the tool is, but we should teach the machine on not losing the tool. And if the machine understands not losing the tool, it means that the machine can predict and can notify users not to lose the tool. As we said before, we have this big understanding of the machine learning is something immense, something huge, and we are just a little dots trying to cope with that. This is not the case. As I told you before, the machine is a high-rated computing system, mathematical agreements and arrangements. It's not that the machine predict without having hunches from you. And hunches, when I say hunches, I say data set and data from you. So going back to the question, because we wanted to train the model, and the machine learning, as we said, works only when there is an agreement on what is the next task for the astronauts. We started to pound neurons, and we started to get near another perspective, as I said before, clockwork engineers. We hired clock engineers, and I'm going to tell you why we hired them. And the difficult task is that after 1 year of developing and training the model, we need to unlearn what we have learned, and we need to roll back to our zero index start point in order to be able to tackle the app with a machine learning embedded. So we came out, inspired by Google Clips, with some fundamentals, and that was like human-centered machine learning exercise. So that what we were saying before, trying to teach the machine how to become an expert astronaut. If I show you that picture, what comes to your mind? Yeah. And that's why we we approach clock engineers, because clock, it's a bunch of 3-4 mechanisms that gives you the time. The clock gives you the time mainly. It doesn't give you anything else. So don't underestimate your common sense, meaning that clock, it's a common sense, and the machine learning has common sense. It's like when we were at school, they gave us a bunch of vowels and consonants, a bunch of text, and with hunches, we started learning how to read. By learning how to read, we started learning how to write. And that's the machine, the same processes is the machine takes when it comes to computing data input and data layers. So we need specific prediction that needed to get trained, and the prediction were the task of the astronauts. But now one step back about the clock. Instead of giving the machine a bunch of tools dispersed everywhere, we gave the machine that model to train on. And we said that the clock just need 4 grain in order to be able to, 4 clocks in order to be able to give you the time. So we were actually teaching the machine, don't look at all these tools. You don't need to look and identify all these tools by themselves. You need to look at the whole process, and you need to focus only on 4 or 5 tools that you're going to be able to understand by hunch what is good for the astronauts in our case and what is not good. Continuity. Again, if I show you that picture and that picture, it's clear that that picture is a clock. This picture is a mechanism. It's not a clock. It could be a clock, but we cannot assume that it's a clock. So by training the machine with the most used mechanism, the machine started to understand that from those mechanisms here colliding with those mechanisms over here, this one was a 98% a clock. But we didn't start with a complicated picture, because otherwise the machine would have used too much data to understand it, spent too much time, and we didn't have no time, not enough data. Consistency. So once the 2 major principles, and there's another one that I'm going to explain to you later on about teaching a machine something, is continuity and consistency. So you need to give the machine a continuity of information in order to be able to understand and allocate this information. And consistency, you need to give the machine, you need to give the machine like a little tip on what is the next mechanism, in this case about the clock. And this is the consistency, so the machine can replicate the continuity into consistency. And another important thing is that we made the machine learning time. Can you tell me why? Redundancy, diversity. 1 hour, it's number 1. 60 minutes, it's 1 hour. 60 seconds is 1 minute. There's diversity in those numbers, but there's redundancy, meaning that every 60 becomes 1. And that was what we gave the machine to understand, that 1 could be 60. 60 could be 1. Try to interpret when is 60 becomes 1 and when 60 is just 60 is a number. But as we say, machine, it's got hunches, but sometimes it doesn't understand what it comes out. I don't know if you see HAL or the Space Odyssey, Dave, I cannot open that. So if you train the machine not to open something, and then you need it to be opened, You cannot pretend that the machine will open it with another input. So as we said before, we need to build trust. And by doing all these exercises with the astronauts and our user, we saw that they were more confident in following the machine because the machine was trained in consistency. So the machine was giving consistency to the astronauts. Was trained in continuity. So the machine was giving continuity to the astronauts. And it was redundant, but diverse, meaning that the tasks were redundant, but diverse themselves. Perfection is impossible, it shouldn't be the goal. As we said, that machine learning, his job is doing prediction. So you cannot ask, I don't know, you use Google Maps, correct? Yes, no. Do you use Google Maps? Bing, whatever. The machine doesn't give you, it doesn't predict where do you want to go. You put an A, Z point, and the machine gives you the best way around. So that's the difference, and you should take in consideration when you're talking about building something with AI or machine embedded. The machine is not going to give you yet, it's not going to give you the end point, but it's going to give you the best way to go through the end point. So you cannot find a needle in a hay, but they're going to tell you that there's a needle somewhere there, and the machine is going to show you the best way to find it. When building with AI and machine embedded, you need to address human needs firstly. And I really encourage you as a developer. I guess you're all developers, correct? Developers? Any developers? Thank you. You need to deconstruct a little bit what it's in your mind. I'm a developer as well, and some of these things were really absurd to approach. I know, just give me an ID, put me there, I'm going to write the code, I'm going to write the data set, I'm going to set to the machine, teach from here, machine learn from there, and then I'm going to have the outcomes. Sometimes it doesn't work that way. Sometimes you need to open your sphere and see and address what human needs. You need to uphold human values when building something. You cannot say the machine to understand sentiment. And mainly, you need to design for argumentation. The machine is nice when it's argumenting. It's nice when it's arguing with you. It's not nice when the machine just follows you. That's just a common software, input-output. I'm going to ask you a couple of questions that might be able to make you understand a little bit how the machine thinks. Well, two questions. The first one is, what relates us to a machine? What is the common objective between us and the machine? Any? What? No. You didn't have emotion when you were born. You started learning them. Consciousness? No, not yet. Survival. The machine needs to survive. We need to survive. And the machine sometimes can be harsh against you because it needs to survive, and it needs to come out with a better itself. Those are my personal point of view. Well, consciousness and emotions, those are your points of view. It's not right or wrong. And what is the difference between us and the machine? Sorry? Yes and no. Well, like at Chase, the difference is that we don't have time. The machine has time. The machine doesn't die. We struggle with ourselves because we know that we're going to die. Hopefully not, but we're going to die sometime. The machine doesn't die. And it's interesting, I can tell you that there's a machine in a lab. The main problem with the machine is the main problem. When you got a problem with the machine and when you see that the machine gets out of control, you just unplug it. End of the story. But when you plug it back in, the machine didn't stop computing, or it stopped computing where it went over there where you unplugged it. And it was interesting because the machine came out with an algorithm that it could generate energy throughout pixel data exchange, meaning that exchanging one pixel data to another pixel data, she was consuming less energy than creating it. Even 0.00001%. But if you put that in a 1,000 year, you're gonna have, it's a bit like the smart grid. So she was thinking about smart grids. And she was saying that I do not need all the energy to be consumed in this quadrant. I just need to divide the quadrant by X and Y rows and columns, and I just need to put and allocate data pixel exchange energy in a battery pixel. Meaning that in a few years, even if you unplug the machine will work. And that's the main difference. If you want to learn a little bit more, we've been working closely with Per from Google, and they came out with some AI guidelines. You should go. I'm gonna give you the link later on. And it's really interesting, especially data collection and evaluation. You can see how you collect data and how you evaluate it. And there's some code samples over there as well that you can work a little bit on those and see what it's like to teach the machine and to have the feedback from the machine. There are actually a lot of companies or teams inside our lab that they are trying to make the machine create data layer from data layer input. So we decrease the data bias in input into the machine. That was all for me. Thank you. If you have any questions, I guess we got some questions.